Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. An intramolecular aldol condensation, aldol reaction with heat, involves a decarbonyl compound forming a cyclic alpha-beta unsaturated carbonyl via I-enolization alpha to one carbonyl, 2. Intramolecular nucleophilic addition to the other carbonyl, 3. Dehydration under heating to give the enone. Moving on to the next step. Jasmone is 2-cis, 2-pentenyl, 3-methylcyclopent 2N1-1. It is a cyclopentane, 5-membered ring alpha-beta unsaturated ketone. The ring has C1 ketone, C2 is equal to C3 double bond, a methyl group on C3 and a Z2-pentenyl chain on C2. The ring closure forms a 5-membered ring. Moving on to the next step. To form the cyclopentane ring via intramolecular aldol condensation, we need to open the ring at the bond formed in the aldol step, the C to C bond alpha to the carbonyl, between C1 and C5 of the ring. Disconnecting the ring gives a linear diactone. The 5-membered ring requires the 2 carbonyl carbons to be 1,5 related, 5 atoms apart, counting both carbonyls, so that the enol of one attacks the other to form a 5-membered ring. The precursor would be a 1,6 diactone, carbonyls separated by 4 carbons. And for the final step, opening the cyclopentane ring of jasmone retrosynthetically, the product has a methyl substituent on the double bond and a cis-pentenyl side chain. The linear precursor diactone would be Z, undec 8Na 2,6 dione, option D AC11 chain with ketone at C2, methyl ketone end, and ketone at C6 and a cis double bond at C8, C9 with an ethyl terminus, which becomes the cis-2-pentenyl side chain after ring closure, and the methyl at C2 becomes the ring methyl after condensation. The C2 ketone provides the methyl group. As the terminal methyl of the methyl ketone enolizes, C6 ketone acts as the electrophilic carbonyl for ring closure, and the cis alkene is preserved in the product. Base, O-, deprotonates alpha to the C2 ketone at C3, forming an enolate. This enolate attacks the C6 ketone intramolecularly to form a beta-hydroxy ketone aldol product, creating the 5-membered ring. Heat promotes dehydration to give the alpha-beta unsaturated ketone, cyclopentane, is equal to jasmone. Option A. Monoketone with terminal alkene cannot do intramolecular aldol, only one carbonyl. Option B. Diactone with carbonyls at C2 and C7, 1,6 relationship, 6 atoms apart, would give a 6-membered ring, cyclohexane, not a 5-membered ring. Option C. Ketoldehyde, aldehyde plus ketone, the geometry and chain length do not lead to jasmone's substitution pattern. Option D. Diactone at C2 and C6, 1,5 relationship, 5 atoms apart counting both, gives the correct 5-membered ring with the right substituents to produce jasmone. Therefore, the correct answer is D. Therefore, the correct answer is option D.